welcome to the deep dive. This time, we're diving deep into the world of crane safety, specifically when those cranes are operating on barges or vessels or anything that floats, really. So this one's for all you safety professionals and crane operators out there, and anyone looking to get their crane operator license. You sent us a bunch of OSHA regulations and interpretations, even a letter to a senator. It's serious stuff. So let's unpack these documents together and see what we can learn.
Yeah, it's serious business when you're dealing with these huge machines on the water. There are so many challenges that are different from land-based operations.
Absolutely. And I think the first thing that stood out to me was that not all cranes are created equal. We can't just stick a land crane on a barge and call it a day, right?
Exactly. You have to consider the movement of the barge, waves, wind. It's just a lot less stable. That's why you have to reduce the capacity when you use a land crane on a barge.
Okay. So how much are we talking about here? Is it a standard percentage or does it depend on the situation?
It really depends on the situation. OSHA standard 1926.1437, which covers all of this, is very specific about how to calculate that reduction. You have to look at the list and trim of the barge, wave action, wind speed, all of that.
So it sounds like a lot of careful calculation goes into it. What would you say is the most important aspect of that whole process?
I'd say the most important thing is the person doing the calculations. OSHA makes it very clear that it has to be done by either the equipment manufacturer or a qualified person, someone who knows both land cranes and the vessel stability.
Right, so they have to understand both the crane and the barge really well.
Exactly.
Okay, so that makes a lot of sense. Now, you mentioned OSHA 1926.1437. It seems like that's the main thing governing all this crane safety on the water. So besides this capacity reduction stuff, what else does that cover?
Well, first of all, it lays out all the requirements for both floating cranes and derricks, as well as land cranes working on barges. It talks about things like work area control, making sure everyone's safe around the crane. And then it also has specific safety devices that you wouldn't normally find on a land crane.
Oh, really? Can you give me an example of one of those?
Sure. One example is the list and trim device. It has to be in the crane cab, and it basically tells the operator how much the barge is tilting or leaning.
Wow. So it's like a constant heads up about the stability of the barge.
Exactly. It can really help prevent the crane from tipping over.
Which would be disastrous.
Definitely. And actually, speaking of prevention, OSHA 1926.1437 is really big on inspections. And we're not just talking annual checkups here. They want inspections every shift, every month, every year. They even want an internal inspection every 4 years.
Wow, that's a lot of inspections. So what are they trying to catch with all those?
It's all about catching potential problems before they turn into huge hazards. They're checking the structure of the crane, the safety devices, the condition of the barge itself, the stability. It's really all about making sure everything is in perfect shape and working like it should.
That makes sense. You want to be extra cautious when you're dealing with such heavy equipment on the water. Now, one of the documents you sent us that really piqued my interest was a letter from a company to a senator questioning a specific requirement. They were asking about the requirement for longitudinal watertight bulkheads on crane barges. Can you tell me more about that?
Yeah, sure. Basically, this company felt that their barges, which were designed by marine architects, were already safe even without these bulkheads, so they didn't really see the need for them.
So they felt pretty confident in their design. How did OSHA respond to that?
Well, OSHA really took the time to explain why those bulkheads are so important. They talked about something called the free surface effect, which can make a barge really unstable.
Free surface effect. I have to admit, that sounds a little ominous. What does that mean exactly?
Basically, imagine water sloshing around inside the hull of the barge as the crane is moving and the barge is shifting. That moving water can create a lot of instability, and it can actually increase the risk of the barge capsizing.
Oh, wow. Okay, I see the problem.
Yeah.
So how do these bulkheads help with that? Do they, stop the water from moving at all?
Not completely. What they do is they act like walls inside the hull. They create separate compartments that are watertight.
So they're kind of compartmentalizing the water so it can't slosh around as much.
Exactly. By dividing the hull up like that, it restricts the movement of the water, which makes the barge much more stable, especially when the crane is operating.
Okay, that makes sense. Now, you mentioned that the company's barges were designed by marine architects. Did OSHA address that at all? Did they offer any flexibility on that bulkhead requirement?
They did. They said that pre-existing barges, especially ones that were specifically designed with stability in mind, might be exempt from the bulkhead requirement, but only under certain conditions.
There's always a but. So what are those conditions?
Well, basically, those barges have to undergo a lot of inspections
Yeah.
to make sure they're actually meeting the safety standards.
Mm-hmm.
And any deficiencies have to be addressed right away. It's really a case-by-case evaluation.
So not a free pass, but there is a path to exemption if they can prove their barge is safe.
Right.
Okay, so we've talked about the capacity reduction for land cranes working on water.
Right.
But can you break down how that calculation actually works? What are the main things you have to consider?
Well, as we mentioned earlier, you have to look at the list and trim of the barge. The wave action, the wind speed, all of those things are factored in.
It sounds pretty complex. Who's qualified to actually do those calculations?
Well, this is where those qualified individuals come in. Remember, it has to be either the equipment manufacturer or someone who knows both land crane capacity and vessel stability. They're the ones who can accurately assess all those factors and figure out what the safe operating capacity is for that crane on that specific barge.
It sounds like you really need a specialist for this.
You do.
Now, what about securing the crane to the barge? Is it as simple as just chaining it down, or are there other methods involved?
There are actually 4 different options that OSHA 1926.1437 outlines. Each one has its own set of requirements.
4 options. Okay, now I'm really curious. Tell me more about those.
Well, the first one is just physical attachment. So you're using things like cable systems, bolting, welding, chains to physically secure the crane to the deck of the barge.
Okay, so that one's pretty straightforward. What are the other options?
The second one is called corralling. Instead of directly attaching the crane, you're installing barricade restraints around it to prevent it from moving,
So it's like building a fence around it.
basically.
When would you use that method?
Corralling is helpful when direct attachment isn't possible, or when you need to let the crane move a little bit within a certain area. It's all about having a secure boundary.
Interesting. Okay, what's the third option?
The third one is using a rail system, kind of like a train track, to guide and secure the crane. This lets it move along a specific path while still being attached to the barge.
A rail system. That's fascinating. Okay, so we've got physical attachment, corralling, and a rail system. What's the fourth option?
The fourth one is a centerline cable system. This is where you attach the crane to a wire rope that runs along the centerline of the barge. It acts as an anchor point, but still lets the crane move along that line.
A centerline cable system. That sounds pretty intricate. When would you use that one?
That one's good when you need a balance between secure attachment and controlled movement. So the crane can be repositioned along the barge, but it's still securely connected.
Okay, that makes sense. So it sounds like there are a lot of different ways to secure these cranes. What's the most important thing for our listeners to remember about all of this?
No matter which method you use, it has to be designed by qualified individuals.
Mhm.
So that could be a marine engineer, a professional engineer who understands floating cranes, or someone with equivalent expertise. You need someone who really knows the forces involved and can make sure the system is strong enough to withstand that marine environment.
Okay, so again, we're seeing how important expertise is in every part of this process. Now, I understand there's a special case with mobile auxiliary cranes, those smaller cranes that operate on the deck of a larger floating crane. What makes them different in terms of safety requirements?
Those cranes actually have an exception to the physical securing rule.
An exception, so they don't have to be physically attached or corralled or anything?
Right, because they're operating on the deck of a larger crane that's already stabilized. They're not subject to the same movement and instability as a land crane on a barge.
That makes sense. So how do they ensure safety without being physically secured?
Instead of those traditional methods, they operate under a specific plan and procedures that are developed by a marine engineer or professional engineer who knows about floating cranes.
So it's a more customized approach to safety.
Exactly. The plan will lay out specific areas where the crane is allowed to operate, any limitations on its movement, and what kind of environmental conditions it can handle.
Okay, that makes sense. So it's all about recognizing that safety isn't always about a one-size-fits-all rule. It's about understanding the specifics of each situation and coming up with a plan that works for that.
Exactly.
This is all incredibly detailed. It really shows how much care and attention goes into making sure these cranes are operating safely on the water. But I'm sure there's a lot more to it than we've covered today, right? What are some other things we need to explore further?
Yeah, there's definitely a lot more to discuss. I think we need to go into more detail about those 4 securing options, talk about their advantages, their limitations, best practices for using them. We should also talk about the importance of training and education in this field and the responsibilities of everyone involved, from the operators to the safety professionals.
Absolutely. Now, before we move on, I want to connect this back to our listeners. Why is all this information so crucial? especially for those who are working towards their crane operator license.
Well, understanding these regulations and safety practices is absolutely essential for anyone working with cranes on the water. It's not just about passing an exam, it's about protecting lives and making sure everyone goes home safe at the end of the day.
That's a really important point. This isn't just theoretical knowledge. It has real-world consequences. So for all you aspiring crane operators out there, pay attention. This information could literally save lives and help you build a safe and successful career.
You're absolutely right. It's not just about checking boxes. It's about understanding the risks and taking steps to mitigate them.
Exactly. And speaking of mitigating risks, let's go back to that free surface effect. You explained it with the water sloshing around. But can you give our visual learners a clearer picture of how those bulkheads actually work to stabilize the barge?
Sure thing. Imagine you have a big container like a baking dish filled with water. If you tilt the dish, the water flows to one side and it could tip over. It's kind of like what happens on a barge without bulkheads.
Okay, so I can see that. How do the bulkheads change things?
Now imagine you divide that baking dish into smaller sections, like with dividers. Even if you tilt the dish, the water is contained in those little compartments. It can't flow freely from one end to the other.
So the bulkheads basically create a bunch of smaller containers inside the barge's hull.
Yeah, exactly. That's how they reduce the free surface effect. By stopping the water from moving so much, it prevents that sudden shift in weight that could make the barge unstable.
That's a great analogy. It really helps understand how those simple walls can make such a difference. Now, we've talked a lot about OSHA's role in setting these standards, but what about the responsibility of employers and crane operators? What's their part in all of this?
Well, it's a shared responsibility. OSHA sets the ground rules, but it's up to the employers to create a safe work environment.
So they're the ones who actually put it into practice.
Right. They need to make sure everyone is trained properly, their equipment is well maintained, and everyone understands the rules.
What about the crane operators themselves? What kind of skills and knowledge do they need specifically to work safely on the water?
Well, crane operators on the water need some special skills. They need to know about the reduced capacity of land cranes and never go over those limits. They need to constantly monitor the stability of the barge, watch that list and trim device we talked about, and maybe most importantly, they need to be great communicators. They have to work closely with the barge crew to make sure everyone is on the same page.
It's more than just knowing how to operate a crane. It's also about the marine environment and teamwork.
Absolutely. It's a team effort out there. Everyone needs to know the risks, communicate clearly, and put safety first.
This has been really eye-opening. Now, before we move on, I'm curious about that letter from the company that questioned the need for bulkheads. What happened with that? Did they get their way?
Well, OSHA was very firm in their response. They emphasized how crucial those bulkheads are for keeping the barge stable. They wouldn't budge on that. But they did acknowledge the company's point about their barges being designed by marine architects.
So there was a little bit of wiggle room.
Yeah, but only a little. They said that if a barge was already designed with stability in mind, it might be exempt from the bulkhead requirement, but only if they could prove through inspections that it met the same safety standards.
So it's a case-by-case thing, not a blanket exemption.
Exactly.
That's really interesting. It shows that you have to use professional judgment and really understand the situation. Okay, so for our listeners who are working with cranes on the water or who want to get into that line of work, what's the one thing you want them to take away from this?
I'd say the most important thing is to remember that crane safety on the water is a complex challenge. It requires specialized knowledge, following the rules, and always thinking about prevention. It's not just about operating the crane. It's about understanding the whole marine environment and making sure safety is at the heart of every decision.
Well said. And remember, folks, this deep dive is just the beginning. Keep learning, keep asking questions, and always put safety first. Now let's get back to those land cranes on barges. We know they need a capacity reduction, but what exactly goes into that calculation?
Oh yeah, that's where things get interesting. Remember those factors we talked about earlier? The list, the trim, the waves, the wind. All of those things play a role in figuring out the safe capacity of a land crane on a barge.
So it's not just a simple formula.
No, it's not. And it's something that needs to be done very carefully. OSHA 1926.143710 is very clear about who can do those calculations. It has to be the equipment manufacturer or someone who really understands both land cranes and vessel stability.
So you need an expert for this.
You definitely do. Because if you mess it up, the consequences can be serious. Like if you underestimate the effect of the list or the waves, you could overload the crane, and that could lead to a major accident.
That's a scary thought. It reminds us that we're dealing with very powerful machines in an environment that can change quickly. Now, earlier we were talking about those mobile auxiliary cranes, the ones that work on the deck of a bigger floating crane. And you mentioned they have an exception to the rule about being physically secured. Can you tell us more about why that is?
Yeah, it's a good example of how safety isn't always about strict rules. It's about understanding the situation and applying the right principles.
So instead of always having to be attached to the deck, these smaller cranes operate under a more specific safety plan.
Right. That plan is developed by a marine engineer or someone who knows a lot about floating crane design. They look at the specific crane, the deck layout, and what they're going to be doing with it. And they come up with procedures and limitations to ensure safety, even without using those traditional securing methods.
So it's like a customized safety protocol for each crane.
Exactly. The plan will say exactly where on the deck the crane can operate, how it can be moved, and what kind of weather conditions are okay.
Okay, so they've really thought about all the details.
They have.
And I'm guessing those allowed areas are clearly marked on the deck so there's no confusion.
Oh, yeah, for sure. Everyone on board needs to know where the crane can and cannot go.
This is all fascinating. It really shows how much planning and preparation goes into keeping these cranes safe on the water. It's not just about the crane itself. It's about understanding the whole environment, the vessel, the loads, and having the expertise to manage all of that safely.
You got it. That's why training and education are so important in this field. The marine environment is always changing, and it's crucial to stay up to date on the latest safety practices.
Couldn't agree more. Now, before we wrap up, I want to leave our listeners with something to think about. We've talked a lot about how wind affects crane operations, but what about currents? How do those play into the whole equation?
That's a great question. Currents definitely add another layer of complexity. They can impact the barge's stability, how much the load swings, even the operator's control over the crane.
So it's not just about the speed of the current. It's also the direction and how it interacts with the wind and the movement of the barge.
Exactly. You have to consider all of those forces together. For example, if you have a strong current going against the wind, that puts a lot of stress on the crane and the barge. It could even push them past their safe operating limits.
That sounds dangerous.
It can be.
So what can you do to stay safe when you're working in areas with strong currents?
The most important thing is to know what the current conditions are and factor that into your risk assessment. You might need to reduce the load even more, change your operating procedures, or even call off the operation if the currents are too strong.
So sometimes it's better to err on the side of caution.
Absolutely. Never underestimate the power of moving water. It can throw some curveballs that you wouldn't see on land.
This has been incredibly informative. But I know we could keep talking about this for hours. There's just so much to learn. Unfortunately, we're running out of time for today. But I do want to encourage our listeners to keep exploring this topic.
Yeah, there are tons of resources out there. You can check out OSHA's website, industry groups, even the equipment manufacturers themselves. The more you know about the risks and how to stay safe, the better.
Knowledge is power when it comes to safety. So for everyone out there working with cranes on the water, or planning to in the future, I'll leave you with this final thought. Never stop learning, never stop asking questions, and always put safety above everything else.
It's a good point. Currents are something to watch out for. You mentioned earlier that we could spend hours talking about all the details of crane safety on the water, and you're right, there's so much to cover. But we are a little limited on time today.
I know, I wish we had more time too.
Yeah.
But before we go, I want to circle back to those 4 securing options we talked about. Can you break down the pros and cons of each one for our listeners?
Sure. So physical attachment, the most common one. It's straightforward, pretty reliable, and usually the most secure. But it can be time-consuming, and it might not work in every situation, especially if you need to move the crane around a lot.
Okay, that makes sense. What about corralling? When would you choose that over physical attachment?
Corralling is good when you need to give the crane a little bit of movement, like within a certain area. It's also good when attaching it directly is tricky, like if the barge has a weird deck layout.
So it would give you some flexibility, but it's still secure.
Right.
Okay, what about the rail system?
The rail system is perfect for when the crane has to move back and forth along a line, like when you're loading and unloading cargo. It's a smooth, controlled movement, but it can be a little less flexible than the other methods.
And lastly, the centerline cable system. When would you use that one?
That one's a good option when you need both a secure connection and the ability to move the crane. It lets you reposition it easily along the barge.
So each method has its own advantages and disadvantages. It seems like you really need to think carefully about which one to use.
You do. The safety of everyone depends on choosing the right securing method and making sure it's set up correctly.
For sure. Now, before we wrap up this deep dive, I want to go back to something you've mentioned a few times, the importance of qualified personnel.
Absolutely. Whether it's calculating the crane's capacity, designing the securing system, or doing inspections, you need people who really know what they're doing.
It's not just about having a license.
Right. You need the training, the experience, and the knowledge to do things safely.
Exactly. And that expertise doesn't happen overnight.
No, it takes time. You have to keep learning, keep up with the latest regulations and best practices.
I encourage everyone listening, whether you're experienced or just starting out, to always be learning. There's always something new to discover.
Definitely.
And remember, safety isn't just about following the rules. It's a way of thinking, a culture that we need to build.
Well said.
So let's all commit to putting safety first, to learning from each other, and to working together to create a safer environment for everyone.
It's been great talking to you today.
Thanks for being here. And to all our listeners out there, thanks for joining us on this deep dive into crane safety on the water. Remember, knowledge is power, and safety is everyone's responsibility. This deep dive was presented by Safety One Source. Until next time, stay safe and keep learning.